mulai.
Okay. Assalamualaikum warahmatullahi wabarakatuh. In this occasion, we will present our group work. First, I will introduce my um, group member. First is Aurelia, then Bismarck, Carla, Dinda, and Gianita. Next. So the agenda is what will be explained in this presentation. First is control unit or CU, then arithmetic logic unit or ALU, memory address register or MAR, and memory data register or MDR.
First, control unit. Next slide, please. Next slide, please. Sorry, I think it's my connection is so bad. Okay. Control unit. Information about control unit. What is control unit? The control unit and its functions are a basic topic in the study of computer organization and architecture. Because it is an important component of the processor architecture, in computer architecture, the control unit is the circuit that guides the operation in the computer's processor. It allows the computer's logical unit, memory, both input and output devices to know how to respond to instruction received from the program. Examples of the device that use the control unit include CPU and GPU. The function of control unit. The control signal sent by the CU is an important part of the computer architecture, used to synchronize the operation of various hardware system components and external peripheral devices connected to the system. The control unit itself consists of four main components: timing and control logic, program counter, instruction register, and instruction decoder. Together, the four main components help to perform many functions of the control unit, which are controlling the movement of data, memory read and write operations between the processor and the main memory RAM, generates the steady stream of clock pulse, generates the control signal, and decodes the machine instruction format and directs the ALU to perform the desired operation. Next.
Okay, the next one is arithmetic logic unit or ALU. Next slide, please. Okay, so the definition of arithmetic logic ALU is, arithmetic logic unit or ALU is a logical reasoning unit. This ALU is a high-speed CPU circuit that is in charge of calculating and comparing. If the CPU is assumed to be the brain of the computer, then there is another tool in the CPU known as arithmetic logical unit that thinks to execute to the commands given to the CPU. How does it work? ALU will work after receiving orders from the control unit located in the processor. The control unit will give orders according to the command contained in the register, whether to perform addition, subtraction, or other processes. Registers also contain operands. After the ALU process is complete, the result that is formed in a register containing the results or another command. In addition, ALU also issues a flag that serves to notify us of the condition of a processor, such as whether the processor has overflowed or not. So the function of arithmetic logic unit or ALU is one part or component in a computer system that functions to perform arithmetic or an logical operation or calculation. Examples of arithmetic operation are addition and subtraction operations, while examples of logical operation are logical and OR. The results of calculations in the ALU are stored in the memory. The, the process from the input to the CPU, the memory, and output device can be seen from the table above. So next,
So the next one is memory address register, or we call it MAR. So information about MAR is in a computer, the memory address register is a CPU or central processing unit. Register that stores the memory address or location from the data will be fed to the CPU or the address to which data will be stored. MAR holds the memory location of data needs to be accessed. When reading from memory, data addressed by MAR is fed into the MDR and then used by the CPU. When writing to memory, the CPU writes data from MDR to the memory location whose address is stored in MAR. The memory address register is half of a minimal interface between a microprogram and computer storage. The other half is a memory data register. The memory address register is used to handle the address transferred to the memory unit, and this can be handled either using a bus approach, which we have used in the architecture, or direct input declaration for the memory. In this case, we will use a bus setting for the memory, therefore the MAR becomes a simple register which sets its output to the value of the required address from the IR or PC when its control signal MAR underscore load is high. The MAR is in a simple microprocessor needs enough bits for the address. For example, if the address requires 8 bits, then the size of the register needs to be 8-bit wide. The memory address register therefore has collect and reset signals and also the same interface to the internal processor bus or MAR underscore bus, defined as a standard logic of direction in out. However, only the first 8 bytes are used. Next, please. So I'm going to explain about memory data register or MDR. Next, please. So what is memory data register? Memory data register is a register of a computer's control unit that contains the data to be stored in computer storage, or the data after a fetch from the computer storage. It acts like a buffer and holds anything that is copied from memory ready for the processor to use it. MDR is a full register. When data is fetched from memory and placed into the MDR, the instruction to one direction. When there is a write instruction, the data to be written is placed into the MDR from another CPU register, which then puts the data into memory. The memory data register is half of a minimal interface between a microprogram and computer storage. The other half is the memory address register. For more complex memory interfaces exist, but this is the simplest that can work. The memory data register contains the data value being fetched or stored. You might be tempted to say that the MDR should be W bits wide, where W is the cell size. However, on most computers, the cell size is only 8 bits, and most data values occupy multiple cells. Next, please. So here are some sources that we take our information from. Next, please.
So these are the sources from our presentation. Thank you for listening.